4 papers in various national conferences and seminars. He is considered to be an expert in long-wall technology and has been instrumental in the introduction of Asia's largest and advanced technology in long-wall in Adriala project of the Singareni Collieries Company Limited. He visited many foreign countries to familiarize with various advanced technologies there and introduced them in the company. He is very sincere, honest, and hardworking officer. We are privileged to have his presence in the webinar despite his busy schedule. The alumni of Mining Engineers Association is grateful to him for all the support he is extended to promote the cause of mining engineering education in College of Engineering, Usmania University, Hyderabad, and also University College of Engineering, Kakatiya University, Kottagudam. Now I will hand over the mic to Dr. M.S. Venkatramaya.
Thank you very much, Saiti, for reading out the profile of Sri S. Chandrasekhar. Now, may I request Sri S. Chandrasekhar, Director Operations and Director Personal Singareni Collieries, who is the chief guest of today's function, to please give his valuable message.
Thank you, Venkatramaya garu.
Thank you.
Thank you very much. Respected seniors from the industry, Bhaskar Rao garu, former Director Singareni Collieries, B.R. Reddy garu, CMD, former CMD, SECL, Amarnath Saab, Venkatramaya garu, B.C. Reddy garu, and most importantly, today's speakers on the subject, Dr. N. Ramana garu, Principal KSM, Mahesh garu, CEO Minematics, Karthik garu, Associate Professor, Stanley College of Engineering, Jayesh garu, Knowledge Lens, Bangalore, our colleague Guruvaya garu, and officers of Singareni, experts, students, faculty of mining engineering from Usmania and KSM, and Fasiuddin Saab and all elder seniors from alumni, a warm good evening. We are very happy to associate with the webinar today on the very important topic of application of IoT in mining industry, conducted by alumni of Mining Engineers Association, OU and KU, and Department of Mining Engineering, OU and KSM. The topic selected by the organizers is very apt to the industry, as coal industry is undergoing a lot of policy and structural reforms. Singareni Collieries, as you know, is one of the oldest public sector in the country, withstood so many challenges, turbulent times, and every time it took it as opportunity to adapt itself to the technologies and the challenges, and try to be pioneer in the various fields. SCCL is a company which adapted a number of innovative things in the underground as well as in open cast. IoT application, which started a decade back, have gained popularity and acceptance during the recent pandemic. SCCL has implemented ERP in 6 modules and also adapted project scheduling in its power plant and also in few of the major open cast and underground projects. Company has also introduced vehicle tracking system for regulating, monitoring the coal transport. Company is utilizing number of softwares for its mine planning and is also using the scanners for the calculation of survey volumes. As we know, IoTs are being used in improvement of communication, automation, business transactions. Introduction of IoT will pave way for remote monitoring, machine-to-machine communication, better decision making. In the recent 12th Safety Conference in Mines, the Government of India also stipulated use of IT and IoT for enhancing, monitoring, improving safety of the men and machinery. Efforts are on way by Singareni to introduce OITDS for hem monitoring, use of radars for monitoring the slope stability, etc. SCCL is always in the forefront with the proposals for application of IoT optimization, productivity improvement, and some of the proposals will be presented by our GM R&D in the teams today. I feel that this meeting is well planned and can be termed as a industry institute interaction in mining industry with academia, industry and students. I thank the organizers for giving me this opportunity. Thank you very much.
Thank you, sir.
Thank you very much, Sri Chandrasekhar Garu, for your valuable advice and your cooperation in spite of your busy schedule. Now I hand over the further proceedings to my senior, Sri K.J. Amarnath.
Thank you, Dr. Venkatramaya, for the welcome address as well as introducing the chief guest and allowing the chief guest to address the gathering. Thank you very much, Mr. Chandrasekhar. Now it's my turn to request Bandhavi, another ME mining engineering student of College of Engineering, Usman University, to read the profile of the first guest speaker, Dr. N. Ramana, on introduction of Internet of Things.
Good evening, ladies and gentlemen, and my friends. Thank you for giving this opportunity to read the profile of Dr. Nagavalli Ramana. Dr. N. Ramana is presently working as Principal of University College of Engineering, KU, Kottagudem. He was also Head Mining, Chairperson Board of Studies in Mining Engineering. He did his BTech from Kakatiya University and MTech from JNTU Hyderabad. He did his PhD from Kakatiya University. He also guided PhD, MTech and BTech students. He also published various research articles in reputed journals and conferences. Thank you. Now I will hand over mic to Mr. K.J. Amarnath, sir.
Thank you so much, Ms. Bandhavi. Now may I request Dr. N. Ramana to proceed with his presentation.
Good evening, all.
Good evening.
So, today's chief guest of the function is S. Chandrasekhar Garu, Director Operations SCL, and Dr. Ms. M.S. Venkatramaya Garu, GM Retired General Manager, and the alumni, and the today speakers, other speakers, Sri Mahesh Garu, Dr. G. Karthik, and N. Radhakrishna Garu, and K.J. Amarnath Garu, the coordinator of this meeting, and Professor Jayant Garu, and Kara Ramchandar Garu, and the other dignitaries in the meeting. Very good evening to all. And so with this, I would like to start my presentation. So thank you for sharing the PPT. So can you see the slides presentation? Can you?
Not yet.
Not yet.
Now option is given, Ramana Garu.
Okay, I am sharing, sir.
Yeah. Now your screen is opening.
Okay, thank you, sir.
Yeah.
Fine.
So very good evening to all. Just before beginning the introduction of IoT, just I want to show you the how the revolution in the industry. So
Enlarge and full screen bettandi. Yeah.
Is it okay, sir, now?
It's fine.
Okay, thank you. So the industry 1.0 and then 2.0 and 3.0. Now it is 4.0. So in the 4.0, it is a 1 minute, sir. 4.0. So the standards are defined by the industry 4.0. So which are like asking the industries to adopt the like IoT technologies, AI, machine learning, data analytics. So these together called as a cyber physical systems. So the cyber physical systems means all the physical infrastructure and the humans connected over a network for controlling and better management of the industries. So this is the industry 4.0 standards are now adapted by all the industries, different industries. So as a part of this, the IoT is playing a major role in the industry 4.0. So the what is IoT basically? So the IoT is like, it is a simple definition. It is just collection of devices and the humans over a network. The device can be as small as, and the device can be as big as any machinery, small devices like a refrigerator, TV, any device, all the different objects which are connected over a internet and can communicate together for a better maintenance, for a better productivity, for a better management, for the improvement of efficiency of functioning of each individual uh, unit or the overall organization. So this is what IoT. So now we can see that the vehicles, home, and a computer, and even AC and refrigerator, and many big machineries, the entire organization, all the machineries which are connected over the internet and can be possible to interact with the one device to the other device, and as well as the human can also control, the management can control the device from the remote and can perform all the different activities of the particular organization from the remote place. Now it is enabled by the IoT technologies. So like what we can do with the IoTs. For example, a manager can manage most of his activities from the remote place. And a farmer, for example, can continue his irrigation while he is on in a remote place. Like today, so many sensors are invented. With the help of the sensors, so he can like monitor the conditions of the field, so which are connected to the internet. He can and see the inputs from the devices, and then he can do a appropriate action. So one can manage all the devices at a home, even they are outside the home. So for example, small example, nowadays the intelligent refrigerators, if you take, like even you need not like bother about the fault or misfunction of the one refrigerator. So the software inside the refrigerator automatically, when it is connected to the internet, suppose as a part of the IoT, so it can send the faults within it or misfunctioning of the refrigerator to the service center automatically without the interference of his owner and anybody else, any human interaction. So it can simply send a request, some misfunctioning is there or some the fault is occurred in the refrigerator. And again from the service side, so they can even they need not visit physically. They can just connect to the that refrigerator over the internet. The problem can be, so if it is a software problem or is it hardware problem. If it is a software, it can be rectified from the remote place. So such a intelligent systems are developed today. So without the interference of human, they can manage themselves. So this is a facility, one of the facility offered by IoT technologies. So like a doctor can monitor his patients, even can do diagnosis, and his expertise he can use, and he can serve his expertise to any place in the world. So recently, I think we have seen that the government of Telangana has announced the implementation of IoT technology for all its irrigation projects to monitor its irrigation project. Recently, it has announced. So it is implementing so there are so many applications in the IoT. So for example, we can see the slide smart city, where every infrastructure in the city can be connected to the over network, and they can sensors can be installed on the machinery and on the buildings, on any organizations. So they can continuously they can pump the data to the cloud. So over that, data analytics will work. On top of that, machine learning and AI techniques will work. So they can track, suppose the particular incidents, traffic jams that may be occurred at a particular place within a few minutes or within a next 1 hour. So that kind of the prediction can be done if you make the entire city as a smart city. Like this is a irrigation, smart irrigation, and so sorry, it is a smart home. Like every the object of your home you can connect to the cloud also through the internet with the help of the IoT. So many sensors can be installed and a smart logging can be done. So this is one of the application of the IoT. And the smart irrigation also, like sensors can be installed in the field and they can continuously send the data back to the server over the cloud, and the appropriate action can be automatically initiated even without human interference. The some of the actions can be like automatically they can be initiated. So like waste management system also in the smart cities now, the government is planning for this also. So this is one of the good application of the IoT. So like this, so there are so many applications of IoT. And if you see that majorly the IoT Internet of Things to become a popular, actually the internet is the first reason. So that has changed a lot of things when the internet was invented. Now internet is allowing, and with the help of the cloud, to connect every physical object, whether it is hardware or software or human, and a combination of human and device can connect to the uh, network and become as a part of IoT Internet of Things, and can communicate each other, can exchange knowledge, can control the other things. So like so many things. These are the some of the like sensors and the equipment which are used as a part of the IoT. And the mining industry is also not exceptional. So they are also started already. The major companies like IBM, Honeywell, and ABB, so they are providing so many solutions now to the mining industry. But coming to the mining industry, so its generalized solution is not possible, I think. So every mine is a specific, every mine is a unique. It has its own features, it has its own limitations, and so that the when we are designing IoT solutions for the mining, I think so we have to study a lot for a particular mine, and we have to design a solution for IoT, I think. So these are the some of the incidents which happened recently in the mines. So there are, I think, more number of incidents, but I am showing you two incidents where is a human loss occurred. So one is Ananta open cast of Mahanandi coalfields, which is on May 2020, and the another one is in again in the same month. So there is in the two places there is a human loss is there. So we lost the humans, and I think that is also one of the most important factor, human safety in the mining, because if you lose a one expertise manager in the mining, so it is a very a big loss to the mine. And presently if you see the mining sector, not exactly this diagram, but the operator like sends the field information, and he may use some devices. He will think and he will act and take the decision. But when he take the decision, he is a closer to the instruments, closer to the machinery, closer to the point of acting. But what is required is like the in the future, or slowly we have to move, we are moving towards the digitization, where the human, like a manager or field worker or anyone, so who is away from the mine location, working location, so he should able to sense the what is happening there, and he has to think with the help of the software, with the help of the analytics, to take the decision. So accordingly he will act, and he will even control the machinery. So some of the things that in the mining industry are automatic resource hours. 1 minute, please. Hours are calculated, and the speed of vehicles monitored in the real time. These are the some of the things that we can do in the mining. So equipment search from the web and the mobile apps, SMS. So secure traffic is required. 100% collision can be avoided in the mining, and like reduce radio communication, and no waiting for a traffic clearance. So like in the mining, like there are temperature, humidity, pressure, and the gases and the water, electricity, which are the the things that are to be measured in the mining industry. So with the help of the sensors, we can take the data, and with the help of a good intelligent program, so we can even predict what can be happened and what the decision to be taken. And if you see that the personal tags and the sensors, vehicle equipment and device tags, so readers or sensors can be attached to them, and the personal tracking and the identifying some of the missing workers, and the controlling the environment within the mining, and the vehicle worker alert system, safe zone. These are the some of the areas I think that can utilize the mine IoT, and as well as data analytics, machine learning, and artificial intelligence together, and can make the mine most safer and most productive and most efficient management. Like these are the some of the head map head the smart element, and so the belt with the variable devices. These are all IoT devices that can be used, like a variable comes under the variable IoT devices ID card. So they have a sensors inserted inside them, so they will continuously pump the data to the server, or to the the device which is away from the station, away from the mine. So that can be continuously monitored, and even for sending the alerts, for taking the decision. So they are useful. I think most of you are very well familiar with all the heavy machinery used in the mining. So these are the some of the two missionaries I could pick the pictures. So so these missionaries are more valuable to for the mining. So continuously the measuring the maintenance of the machine is very very important. So with the help of the IoT, so you can sense so many parameters, so that which are interested by the domain expert, by the mechanical engineer or the mining engineer. So that can be with the help of these simple sensors we can insert to the machine, and they can send the data back, and they can be used to take the decision. So these are the some of the human safety in a mining using a automatic IoT devices like such, and rescue robots in a mining safety elements. So these can be used. And finally the IoT architecture. Finally, IoT architecture. So basically, any IoT architecture, if you take, even in the mining or even in any industry, if you take, so the first part is the getting the data parameter from the device or from the place. So that can be done with the electronics devices, and the electronics devices which are attached to the mechanical devices, and which store the data into the cloud. Then the data is immediately processed, pre-processing is done. So after that we have to apply some analytics, and over that machine learning, over that again artificial intelligence. Then the decisions will be sent to the feedback will be sent to the manager, appropriate manager, and the field workers, engineers, and to take the decision. And sometimes without the interference of these people also, if in the case of emergency, certain decisions can be taken. So that with the help of the intelligent devices, intelligent machines. So that is possible. But the major problem in the mining, so when we are interacted with the R&D of the Singareni, so I two visits we made to the office, and we have interacted with the officials. So the communication is a major problem in the mines. The signal is one of the problem. So even that can be also can be overcome. We can overcome that also with the help of the so many communication devices are available. Point to point communication devices are available, and with the help of that, the mine in the entire mine we can build a private network, so that can connect to again to the internet. So once it is connected to the internet, so the manager of the mine, or the engineer of the mine, expert of the mine from anywhere, so he can monitor and he can give a suggestions. Even he can do a certain services to the machinery also. So that can be done communication is a major problem within the mine or in the underground, and even in the open cast also. In some places signal, that is a problem. So that can be overcome by using a proper communication technology devices. We can establish the local communication network, and again that can be connected to the cloud or internet, so we can overcome. But in case of mining, so the requirements are specific, requirements are different from mine to mine. So the lot of discussion and a lot of field work and lot of like experimentation needs to be done before like finalizing a solution. So some of the solutions which can be like adapted to over the range of mines, like we discussed, one problem is expressed by the R&D of SCL, like automation of shovel and dumper operations and availability of the data and monitoring and all. So that kind of things can be like over a different range of mines, once it is adapted, can be implemented. One more problem in the mining, I will just complete within a 1 minute. One more problem in the mining is you are just importing the machines from the different vendors. Even the machine is very well designed, and so much of sensors are available, and the integrated some devices are embedded within the machine. But when you want to go for IoT solution, so interoperability is problem, because the different machine is supplied by the different vendors. So communication we have to establish with the machine to machine. So for that we need to work actually what kind of protocol is that device is using, and we need a permission to access the device from the vendor. So once that is available, it is very easy to like implement some of these solutions in the mines. So with this, so I now end my presentation, and I thank you the organizers for giving me this opportunity, and thank you one and all.
Thank you, Dr. N. Ramana, for a wonderful introduction on Internet of Things, especially pertaining to various industry as well as mining. Now it's my turn to request Ms. Akila Saiti to introduce the next speaker, Mr. T. Mahesh, who is going to deliver a lecture on application of IoT for optimization of fleet in open cast mines. Ms. Saiti.
It's my privilege to read profile of Sri Mahesh Kumar T. Mahesh Kumar T graduated in mining engineering from KSM or OU and did masters in industrial engineering from NITIE Mumbai in 1996. Later, he worked with Tata Steel, Sonata Software, and Capgemini before founding Mindmatics Solutions in 2018. He has over 2.5 decades of experience in both operations and technology consulting. His expertise lies in using technology to optimize operations and increase efficiency. Currently, at Mindmatics, helping mining, construction, and manufacturing companies to gain visibility of operations, identify bottlenecks, and improve efficiency through the use of technologies such as IoT, analytics, and data science. Today, his presentation is on IoT as an enabler to improve productivity in open cast mines.
Thank you, Ms. Saiti. I request now Mr. T. Mahesh to proceed with his presentation. Please.
Yeah, thanks Akila for the introduction, and thank you for all the dignitaries and luminaries present here, and particularly Sri Chandrasekhar Rao sir and Dr. M.S. Venkatramaya and Sri Bhaskar Rao sir and Amarnath sir and my co-speakers. Quickly, Dr. Sir, Dr.
You can share the screen.
I can share, right?
Yeah.
Yeah, as you have seen, actually my background has primarily into industrial engineering, apart from mining, industrial engineering and technology part of it. So that is where we try to make an attempt to how we can optimize the operations with the use of technologies. And with the new developments in the technology such as IoT and data science, we try to make an attempt how we can do it in mining. Okay. So directly getting into the work, like in OpenCast, this is a typical work situation we would have it. I just want you to be familiar with the slide because this is something I'll be using going forward. So broadly, we have various areas within the OpenCast wherein we have loading. You have dump yard, could be OB or waste dump yard. The terminology, I try to put it common for both metal and coal because we are also addressing students here. And we have a crushing plant or a CHP in case of coal, and we may be having a weigh bridge. After for every extracted mineral or waste, it is usually weighed in metal mines so that we know how it the output at every stage of it. But it is not a common practice in coal, however. So we know excavators are concentrated in a cutting area or the loading zone and supported by the dozers also, and trucks transport and dump at the waste dump yard. And so just register this slide because I'll be putting how the technology works on this slide going forward. Okay. And what are the major concerns, major priorities, or the issues that we want to address in the OpenCast mines? One of the key things is the fuel consumption, which is a A category. It is the single most cost factor in the working capital of an OpenCast mining because of the huge heavy equipment we are using it. And because these are a huge equipment, the operating them is also challenging. And there is a constant endeavor to ensure that the fleet can be optimized or better utilized, how we can improve the productivity of it. That's the engine. And we also want to try and understand what are the bottlenecks actually in the whole operation in terms of where the dumper is going slow or the waiting times are higher, the idle times, and then any breakdowns and things like that, where we want to, how do we identify that? So we try to put in IoT and a little bit of analytics on that, and how we can derive is what the solution is all about. And of course, technically, when we are trying to put it in analytics as the principal, KSM principal has already highlighted and the R&D general managers have already identified, the communication within the mine is a big challenge. And I would like to discuss that component, how we try to address that, and then how what our solution is all about. So using that, we developed a solution called MineOptic, which broadly comprises of production and maintenance and safety management. I'm not going to details of all these things. I only focus on the concept part of it. Now, any IoT has got a 4-layer system generally. At the bottommost layer, we have the hardware or the devices, or it's a group of sensors or whatever we call it. It is basically a data capturing unit and a logger kind of stuff. And then we have got a layer above that, which will actually enable send the data to the servers, wherein we do the process intelligence. Means whatever the data we have captured, it has to be interpreted into a meaningful information that is helpful to the mine managers to act on it. And above that, we put operations inside, which is an analytical layer. This will help us to do the kind of analysis for the mine managers so that they take better decisions, and it is more towards improving the productivity of the operations. Now, coming back to the typically how the asset monitoring is done, is the same slide what I'm using it. So whereas we have got a server which is sitting in the mine office, now it has to be connected to the various equipment in the mine. So this is a standard mode, whether you put a Wi-Fi tower or set of towers and interconnect them, and so that you capture the data from that, or you put you make use of a GSM in case of mines where the ore body is almost near the surface, where the connectivity is reasonably good, kind of thing. And this in turn, connects to each of the equipment and captures the data directly. Now, even in this condition, the challenge is the equipment cannot skip the shadow areas in the mine, because the mine is planned as per the ore deposit availability, not based on the towers positioning. So the connectivity, it may not reach to each and every corner of the mine. And most of the times the excavators and trucks work at the corners, at the blasting happens at the end of the benches. And usually connecting them, reaching them is a challenge whenever a new blasting happens. And often we lose data and we don't understand why the truck or excavator are there, but they are not really making a meaning to the mine managers. Okay, and we try to address this portion. So again, we are coming back to the same four layer thing. So what we have brought in is mainly this is it. So instead of making a hardware which is a simple entity which just collects the data and logs it, we made a hardware which is more intelligent. The processing, whatever the interpretation of the data, what we are doing in the server, we brought in all that intelligence, majority of the intelligence into the hardware itself for each of the equipment. So when I'm putting it in an excavator, I say what kind of intelligence we should have it, and we put only the related intelligence. And similarly, when we put it in the truck, the kind of intelligence required for the truck, we put it. When we put it in the dozer, what kind of. So what happens? This enables us to know what activity it is doing. It monitors at its level only. It derives the it monitors all all the events within itself and derives the activity what it is doing it, and that helps us to can translate that into what kind of trips it is doing, production, and then idle hours, and all those kind of things we can derive it. Now, since the intelligence we have pushed into the hardware level or the device level, what happens, the amount of communication that is required or the dependency on the network will come down for me significantly. So whether there is network or not, I'm not really concerned. Now, how we are achieving it is what we are trying to, I am showing it in the next slide. Now, if you see, the hardware is made a lot more intelligent. Now, there is one more section, one more advancement in the IoT, which is called Internet of Intelligent Things. That means the things are not just dumb things which just collect the data and send it to the server, but what they are intelligent enough to process it itself and interpret the data, and accordingly it will act, whether it should be sent or not, or it should be communicated to the nearby equipment, or what it should receive from the equipment, and things like that. All these decisions are made within the device. And now these intelligent things are embedded in each of these equipment, whether truck or excavator. Now, what these things do, they scan the environment. That means it will sense who are all the nearby. That is one. And it will also communicate with the equipment, dependent equipment. And when it is communicating with the dependent equipment, it knows what data it should get. Say, for example, truck is there. It knows what kind of data it should get from the excavator, what kind of data it should share it with the Weybit, what kind of data it should share it with the server. So, and accordingly, it takes the data, process it, all this data, and then saves it, and then sends only the data what is needed to the server. That way, by dependency on the network itself will come down. And whether even if the network is not there, my data authenticity is maintained well within the device itself. And another advantage is there is no single point of failure. If the network is down, I don't really require to worry. You still have the data authentic, saved locally. Once the network comes in, you collect it. Even if the network is not available, you go to when it comes for parking, you just collect it. You put it the mobile phone and collect the data and go there. That is so simple, as simple as that. One of the main reasons is building that intelligence into the thing or device. Okay, now, yeah. So what are the other advantages? Like one is like no dependency on the network comes down, and the device itself will. Sorry, and then what happened? The other advantage is this hardware requirement. You mean the server configuration itself will come down, because no more it is involved in processing or interpreting the data, because all that intelligence has already gone to the thing level or the device level. So now what happens? My server requirements itself is very light. And because of that, actually your analysis and things like that will be much faster, because the focus will be more on analysis rather than compiling the data and stuff like that. Now what is the other advantages at the field level? Now all the data, when the data is communicated across, lots of automation is possible. There are high degree of possibility automation. For example, at the weighbridge, what happens at the weighbridge? The truck comes, gets weighed, and the operator says like, no, okay, now you are fine. It is logged, you move. So this is all the communication. He's doing nothing else. Now, a truck and excavator are communicating among themselves based on the context. So what happens is the weighbridge directly will talk to the excavator, directly talk to the truck. It will tell you what's its data. Now you are ready, you are weighed, you can move. So there is no operator involvement there. Now because of that, what happens? These operators get upgraded. Their productivity increases in terms of taking care of all the work around weighbridge, rather than doing that mundane routine activity of selecting it and then stop, take the weight and then sending it off. Same thing happens even at the crushing plant. When it goes to the crushing plant, you have got two things to be decided for the truck. Either it has to unload it at the hopper, or it has to unload it at the stockyard. It is based on the availability of the crusher, because of whatever the reasons. Now, as the moment truck enters the crushing plant, then he will get an information immediately that what he needs to be done. So that way what happens, he's directly going to the stockyard or the hopper for unloading it. So that way the entire cycle time comes down. That's one part. Another is, once he comes back and then waits for the excavator for loading. Now what happens, as he does each of these things, the events within the truck are monitored by the device. It is also scanning whom it is working with, and it is also exchanging the data. Now, because of that, the truck knows what activity it is doing, whether it is waiting, getting loaded, or traveling with load, or empty, things like that. So now, based on this, the state of the truck is decided within the truck itself, within the truck device only. So once all this data comes to the server, what happens? I know how much waiting time is there, how much waiting idle time is there for each of these equipment. And that will help us identify actually what are the hours or which are the areas we need to improve. So there is one more point which we try to do. It is not the utilization alone which will help improve the production. It is the productive usage of the equipment which will be much lesser than the utilization. The difference between utilization and productive usage is the idle hours and waiting hours and things like that. So understanding and analyzing these areas will help the managers improve the productivity. That is what we are trying to bring it through this solution. I hope I'm trying to make it a point, but yes, there are a lot of, and I'm not talking about truck dispatching system in real time. It is not OITDS. So because all this is logged within the devices, when it comes in an area where it is connected to the server, it will throw the data. Even if it is not, when it gets connected, it will throw the data. But all the data is authentic and then saved locally and safely, securely. Now, how do we optimize it? This is one point which I wanted to tell. I am sure that most of the experienced mining engineers are familiar with, but just for the benefit of the students, I want to tell. So what happens is for every shawl, for every excavator, we need to have certain number of trucks. so that the waiting time of the excavator is less, or the waiting time of the truck is less. So there are two curves. This is the excavator. As the number of trucks increase, then the waiting time of the excavator will reduce. Similarly, as the number of trucks increase, the waiting time of the trucks will increase. So how do we identify this point? This is what we can arrive at once we have got this activity level data, which we are trying to derive it through this system, right? So this is what I'm trying to say, like, how we can optimize the fleet. Similarly, how do we optimize the auxiliary? These are that is what I showed is for more for the production equipment. Similar thing can be done for the auxiliary equipment. How do we do that? I'm just giving two examples, but we can extend it to quite a few more. Another thing is we have got a dozer. So if the dozer is effectively dosing the material near the excavator, then what happens? The cycle times of the excavator will come down. Loading cycle time will come. Otherwise, it will spend more time in piling up the material around it and then loading the trucks. So monitoring utilization of dozer will help us know how better the shovel can be utilized. So how do we do that? So we see, like, how many times it has dosed near the excavator, and how long it has stretched, and how frequently it has done it, and what point of the day it has done it. Like, is it immediately after blasting, or night hours when there is no need to work and things like that. At the end of the day, what is monitored without IoT is only the working hours. But how those working hours are really spent, we won't be able to know. And that is what we are trying to. We can do that using the IoT. And yes, even though the dozer is working near the excavator, we may not be having the connectivity, but our architecture will enable collect this data through this, what I call totally offline networking mechanism. In this, actually, the truck is part of the digital network, rather than having really a network established across. Like, a truck will help carrying the data across the mine and to the server at the end. Similarly for sprinklers. So sprinklers, we can even monitor what amount of water was sprinkled at which segment of the road, and what point of the time, how frequently it was done, what segments were covered. And because of that, like, how good the dumpers were moving, the consistency in the speeds of the trucks, and all those can be interconnected, and then unless that will help us to know how effectively we should do. And sometimes what happens when today we do not have the controls on the water pumps in the sprinkler. Because of that, what happens when the sprinkler gets slow, usually at the turnings, then you will have huge water line. And then what happens, it will also make the road slurry and slippery for the trucks. So similarly, when it is going, sometimes we don't even get the water. So all these things we can control that using the IoT, when based on the speed, based on the turnings and things like that. So that way, what happens, we can make all of the roads can be uniformly sprayed, so that the quality of the road is throughout same. That will help the dumpers move pretty more efficiently. Okay. This is something which I'm trying to talk about hardware, what kind of hardware we should use it and things like that. I'm a big no-no to use an Android Linux-based hardware because of some reasons, and because of technical reasons, which I'm. And there are quite a lot of business operation benefits, which I mentioned majority of the time. It is basically we are trying to optimize what should be the fleet size or the combination of it, and how much time the fleet should be operated, and so that actually we get the effectively the output. At the same time, we don't spend too much of fuel. We don't burn too much of fuel and the manpower on that. So that's what we are trying to bring in. And the solution what we built has got broadly these three things, three benefits. One is the detailed operational analytics. Whatever the data we are bringing in, we have created a totally detailed analytics layer that will help you analyze on different parameters. And of course, trips is a very basic thing, and we break the trips into small, and then identify how much time it is taking and what is the lead it is going through, and which excavators it is working with, and which areas it is dumping. So many other parameters which we will discuss it in detail when we in subsequent opportunities. Another is flexible and pertinent architecture. As you all know, communication is the key, is the bottleneck in open cast mines. And however good it is on the surface, as we get into the mine, it becomes really inconsistent and poor. And that is what I feel we have cracked it totally innovative way. And we, for that purpose, we have built our own hardware, which is totally scalable. Tomorrow, today you have these only basic events which I'm capturing, but tomorrow if you want to do health monitoring, tying up with OEMs and getting the protocols, integrate with their equipment and get that, and then do real-time health monitoring and do predictive maintenance. Yes, that is easily can be done without disturbing the existing hardware. So the hardware, whatever we have developed, is totally scalable to add any other additional feature into that. That's what we want to do. And I think that's in brief my presentation. And basically I want to introduce our solution and how we are trying to address the main problems in the mining. These are my contact details below, and would be glad if you have any of the questions taking up. Hello.
Yeah, thank you, Mr. T. Mahesh, for a wonderful presentation. I'm sure participants will have a lot of queries. I think we request the participant to put it in the chat box, or in the end, we will try to address their queries. Thank you very much. Now I request Ms.
Sir, please
Bandhavi.
stop your sharing, sir. Mahesh, sir.
Are you able to see it, sir? This is.
Yes, sir. Please stop your sharing, sir, so that we can share some.
Okay.
The PPT this is okay.
Yes. Yeah.
Thank you.
Thank you, Mr. T. Mahesh, for a wonderful presentation once again. Now, may I request Ms. Bandhavi to introduce the next speaker, Dr. G. Karthik, who will be talking about application of IoT for open cast mines.
It is my privilege to read the profile of Dr. Ganta Karthik. Dr. Ganta Karthik, born in Burhamiyapet, Illigate, Karimnagar, Telangana state. He completed BTech and MTech from JNTU Hyderabad. Completed his PhD mining engineering from NIT Rourkela during 2013 to 2018. He published various technical papers in 15 international journals and 5 national journals. He presented papers in 12 international conferences and 24 national conferences, published 1 patent. Research areas of interest include landslides, slope stability, Internet of Things, wireless sensor networks, and soft computing. He was conferred with Young Scientist 2019, organized by International Association of Research and Development Organization IARDO, and Homi J. Baba Award 2020 by Eudoxia Research Center. Dr. Karthik is also a member in various professional bodies such as UACEE, IAENG, IDES, IFERP, IETA, and ASR. He is also extending his services as an editorial board member in various international journals such as SCIREA, Journal of Electrics Communication, and Journal of Advances in Wireless Communications and Networks, and many more. He is also extending his services as Executive Officer and Associate Research Professor for Eudoxia Research Center and Global Journal Secretary of International Electronic Device Development Association, IEDDA. Thank you.
Thank you, Ms. Bandhavi, for the wonderful introduction. I now request Dr. G. Karthik to take over the presentation. I request him to please complete his presentation within 10 to 12 minutes.
Sure, sir. Thank you. Thank you very much. So, Ms. Bandhavi, thank you very much for my introduction. So, and respected chief guest, Mr. Chandrasekhar sir, and the other uh, guest speakers and coordinators of the webinar, very good evening to all. This is Dr. Karthik, who is in front of you. I am going to share my screen.
Thank you, Karthik, for joining. In spite of your busy schedule, he has become father only last evening.
Oh,
Thank you, sir.
congratulations, congratulations, hearty congrats.
Thank you, sir. So actually, I am going to discuss basic idea. Already Professor Ramana sir and Mahesh sir given the introduction about the Internet of Things and its applications in the mining. So I am going to concentrate on only opencast mines. So before going to that, I will give the small introduction about what is the need of IoT in the opencast mines, or indirectly we can in the mines. We know that the Internet of Things are nothing but so connecting the devices to the internet. So there are the different applications for the Internet of Things, like in the practical, in the real field also. So we are going to concentrate on only mining. So basically, if you want to implement the Internet of Things in any industry, first what are the components are there in the Internet of Things? First we need to identify the address. We should assign the address either IPv6, IPv4 like that. After that we should select the proper sensor. After that we should select what kind of communication we want to use. So that means we want to use the Wi-Fi, or we have to use the WiMAX or LoRa or 5G communications or 4G. So that we have to finalize. After that we should select the hardware components. What are the components, or means what are the hardware, means what are kind of the controllers we want to utilize, and what kind of other hardware requirement aligned with the sensor. After that we should go for the application part. So that is a small introduction about the IoT. So coming to the application in the IoT to the mining industry is that we know that in case of opencast mines, we have many parameters to be monitored. That means especially in the rock mass. That means rock mass as well. That means we are considering as a slope stability. So if we the conventional systems to monitor the different parameters in the opencast mines or underground mines, that we are considering it as a geotechnical sensors like tilt meters, extensometers, or conventional load cells. So all these are geotechnical sensors, and we cannot make that sensor to enable with the IoT, because if you want to make the IoT, if you want to make the system, you want to make the IoT system, that should be a smart sensor. So conventional sensors are not smart sensor. It is very difficult to convert the conventional geotechnical sensors into smart sensors. That's why we have the ready-made available smart sensors available. So that smart sensor means smart sensors are nothing but which can capable of integrating with the IoT. So such kind of sensor we have to decide, and we have to replace the conventional sensors with the IoT enabled sensors. So actually the problems in the conventional sensors are we need a separate manpower to collect the data, and also the installation process is difficult, as well as we cannot get the continuous data, means only few whenever the operator is go and when he be able to collect, so particular interval of data only we are going to get by using the conventional system. To overcome that, we are planning to introduce the IoT systems in the mines. So in case of opencast mines, the major problem is slope stability. So in case of metal mines, or if you take the coal mines, and if you take the dumps also, the problem is slow failure. And if you go for the hilly areas, there is a problem is landslides. To all these things are the major problems in the opencast mines. So these kind of problems can be overcome by using the advanced IoT technology. We can call it as an industrial IoT. So actually, so what is the major cause for the slow failure? We know that whenever the driving forces are overcome the resisting forces, generally slow failures happens. So what are the factors affecting the slow failures are like this. So basically surface runoff and surface structures, rainfall, all these kind of parameters affecting the failure, slow failures. So you can see different failures in the Indian mines. This is the dump failures at SECL mines, Almai mines, and this is a Rajmahal mines where I have stayed around 3 months, and I have monitor with the conventional systems. You can see this is the conventional system. So if for monitoring the cracks in the opencast mines, it means I have installed the extensometers. Every time I have to go with the data log, and I have to collect the data extension of the crack like this. So you can see this is the latest June 2020, and it is a open cast mines at Myanmar, around 174 people are killed at this landslide. So this is the problem in the open cast, major problem in the open cast. These are the some of the incident which happens in the Indian mines. So actually to overcome this, we are using the total stations, or basically conventionally we are using the total station. Apart from that, we have the slope stability radar scanners are there, but the cost of the slope stability radars and scanners are more than 3 to 4 crores. So in this presentation, I am going to present a low cost indigenous sensor by which we are going to monitor the slope movements. So you can see that. So this is the problem in the conventional systems. Here I am monitoring the total station. Here I am monitoring with the extensiometer. There is a data logger for the extensiometer. So to overcome the problems in the conventional system, also to reduce the cost of the advanced system by using the slope stability radars and scanners, we the cost is more than 3 to 5 crores. So that's why we have integrated the indigenous monitoring system. By that, we are going to monitor the slope movements on the surfaces. So you can see that this is the one method by which we have monitored the local movements in the mine. So by using a tilt sensor, this is IoT enabled device. So by which we can also get the data available through the internet. This data can be accessed by the any persons in the world. So this particular concept we have not installed in the mindset, and we have designed one opencast model, and we have given the manual movements to that particular model, and we have observed the data in the internet. Like this, we have done the three-dimensional data we got like this. So and we have also placed the different some alarming system for that. Whenever the movement crosses that particular limit, automatically that will give the alarm. So that also we have tested in the laboratory, and this is the proposed method we have submitted to the Singareni. How we are going to install the integrated system in that mine. Like that, we in this like this different location, we have to first we have to mount the given integrated system in the environmental protection box. After that, we should place in the different locations in the mine. After that, we should design separate network to the particular mine. After that, we should communicate to the internet. So that this is the plan we have submitted to the Singareni. So and another method, by using ultrasonic sensor also, we can predict the slope failures and landslides. So this we have done in the laboratory. And another method, by using a three-dimensional accelerometer, we have done some test for getting the ground vibration data by using the blasting. So near structures also going to be flashed. Suppose some civil structures are available near to the mine site that are affecting by the ground vibration due to the blasting. So conventionally, as per the DGMS rules, mine management are collecting the ground vibration data using the minimate device. So the minimate device, a separate person need to place the minimate device at particular location during the blasting time. To overcome that, we have designed a three-dimensional. We have utilized the smart sensor by which we can get the displacement data, and we have converted that displacement data into peak particle velocity. That means in terms of vibrations, and we have calculated, and we have installed in the some metal mine in the Rourkela. Near the Rourkela, we have installed this integrated system, and we have compared our data with the conventional minimate also, which the results obtained by the IoT integrated system as well as the minimate data, almost we have got the similar data by both the systems. So another concept, we have also designed the environmental monitoring system for the open cast mines, and we have done the laboratory testing, and we have also done the field testing in the city. We have not installed in the mine site. This also means this is the IoT based real-time monitoring of the industrial environment. So this is about the monitor. We have done the ground vibrations as well as slow monitoring using the smart sensor and IoT technology. After that, we have also, as the part of my research work, we have done some work by using the time domain reflectometry. This was a well-known technology for the monitoring on the subsurface movements in the underground, in subsurface movements in the open cast mines. So these subsurface movements can be captured by this time domain reflectometry, and the sensor part we have purchased from the USA, and the communication part which we have designed in the our laboratory, and we have installed this IoT based TDR system in the open cast mines, and we have monitored around 6 months in the open cast metal mines at the Mile Nagpur. So the concept of this, just whenever we are going to utilize the coaxial cable as a sensor, and that particular coaxial cable we are going to install in the by using a driller, we are install that coaxial cable in the mine site, and whenever the deformation happens across the cable, that can be detected, and that we have communicated to the surface, and after that we have communicated to the internet also. So this is the major part in that particular system. So this is the sensor part in that particular system. So means the coaxial cable act as a sensor in that particular system. Whenever any deformation experiences, the coaxial cable experiences the deformation, automatically that can be detected, and that can be communicated. If the deformation is more, automatically that will give the alarm, so that the people, those who are working nearer to that particular location, can be alerted, and they can move from that particular location. So this is the basic concept for this reflection theory, means how that particular sensor can work. So before going to install in the mine site, we have done the testing in the laboratory. So we have designed the opencast model. This opencast model we have utilized for the using the smart sensors, and this for TDR system. For all the model, all the concept which we have designed in the laboratory, that was tested by this particular model, and we have got the data, and after that only we have installed in the field. So as we know that the major problem in the open cast mines or any mines is the signal problem, whether the communication problem. I can say the communication problem. The communication problem is overcome by by installing the multiple routers at the different locations, so that we can communicate the data to the end node. So instead of using a single one-to-one node, if you use the multi means mesh network, so that if any module missed in between, if any module is not working in between, that can communicate to the other module, and like this we can design
Dr. Karthik,
yes sir.
Because we are running short of time, may I request you to go to the conclusions, because this
Yes,
detailed presentation we will make when it is convenient to you physically to the students.
Yes sir, definitely. Thank you, sir. Yes. So this is the field site which we have selected in the Nagpur mine. This is the open cast mine at Mile Dongri Kujur mine. So this is the plan of that particular mine. So we have done the communication testing there, and after that we have installed, and around 6 months we have installed our system, and we have monitored, and we have given the training for the mine employees there, and after that they can able to monitor they have habituated to monitor using our system, and they have done they have done the monitoring by using our system. After that we have also compared the data with the total station data, so both we have compared. So with this, I can conclude that there are many applications in the open cast mines by which we can install the IoT system by using a smart sensor. And in that we have done we have done the ground vibration monitoring, slope stability, as well as environmental parameters. So these three we have done in our laboratory, and some we have tested in the mine, and some we have not yet tested in the mine. And we have also proposed some project to the Singareni mines also, along with Professor Srikanth sir, Kakte University. So if you have any queries regarding this presentation, you can ask me. So finally,
Thank
you
you, Dr. Karthik, for a wonderful presentation on use of IoT, especially in OpenCast, to enhance productivity and safety. Thank you very much. Now I request Ms. Saiti to introduce our next speaker, Sri Jayesh Sripadarao, for his presentation on digital mines powered by IoT.
Thank you, sir. I'm very glad to introduce Mr. Jayesh KS. Jayesh KS comes with an extensive experience in managing complex programs or products and leading teams across global environment. He has been managing large teams to deliver critical programs which enables the business towards digital transformation through efficiency business strategy. He has extensive project experience in technical, managerial, and business consulting roles ranging from web-based client or server and being data-based information systems, translating customer needs and technology direction into product definition.
Thank you, Ms. Saiti, for the introduction. May I now request Sri J.R. S.R. Jayesh to proceed with his presentation.
Thank you, sir.
That option is there. You can share the screen.
Yeah, started sharing my screen, sir. Is everyone able to see my screen? Hello?
Yeah.
Yeah.
We are not able to, yeah, now it's start.
Yeah. Thank you, sir. Thank you, Dr. Venkatam Garu, for getting me this opportunity to be a part of this great webinar. And I feel that privileged to be among all of you. So let me not take too much of your time. So this is a solution which we have kind of partnered with CSIR Simfer Dhanbad and selling this solution called as a digital mind, which is powered by IoT. So this is a small introduction about what is the things knowledge lens as a company brings in. So we are a small company of around 400 people, been into business from past 7 years, and have around 3,000 customers in India and some Fortune 500 companies in US as well. So we are kind of big data analytics, machine learning, AI, IoT services, or these are some of the major services what we bring in. So we have been kind of a major service provider for environmental monitoring in many of the pollution control boards across different states, as well as the Central Pollution Control Board. We do have our own industrial IoT platform by name Islands, which has got extensive features like predictive maintenance, unified web SCADA, or secured IT/OT integration, wherein it will eliminate the risk of any kind of data being lost or being hacked into. You have an option to kind of have a digital twin using virtual sensors, which will help you to reduce downtime. We do have AI-enabled analytical apps on the same platform, which will help the business to take critical decisions based on the data. So going to the solution, all this hardware is all kind of made in India hardware, which is certified by DGMS, which meets the IS/IEC standards. So why do we need to go for the digitalization of the mines? Very importantly, it is the man and the machine safety. The collaboration between the man, human beings, and the machine is very critical in any mining industry. So we need to have a safe and collaborative operations, which will ensure that you have a sustainable and reliable workspace, which is again through a digitally enabled mining workforce. So we need to have smart systems which are talking to each other, as well as talking to the human beings as well. So when you have smart systems, you will have the data generated, and that data is kind of a mine itself in itself, so that you can arrive at a decisive or valid decisions to run the business. And this entire digital mine process can be automated, wherein the entire operations as well as the machine workflow is operated efficiently. So just to put a kind of a solution overview, I have just taken an example of a coal mine here, wherein we have placed different sensors at different locations in the mine. And again, as you can see, we have built a network using wireless routers, because the major challenge what we have in mining is, as Dr. Ramana was talking about, the communication. And if you are doing any communication through the cabled mechanism, the chances that there are a lot of times the cables get cut and network connectivity is lost. So this solution is kind of without a wire, or it's a wireless connectivity network, wherein the routers will talk to each other and create a internal mesh wireless network, and that is again hooked up to the different IoT devices placed at strategic locations within the underground mine. And that starts kind of giving you the data continuously, which is acquired, put into a system, and then massage it further to take any kind of decisions or set up any alarms or notifications, and even kind of do a predictive analytics, all those things. So a very high level bird's eye view of what this solution offers you is predictive analytics of slope or landslide monitoring, which is very critical in an open pit mine, intelligent miners tracking, which is very critical in an underground mine, predictive analytics for fire and explosibility, AI enabled strata monitoring, e-governance, which is again part of our regulation. You would have even flood forecasting through smart stowing practices, which is again driven through real-time water level monitoring, and any kind of exceedances are notified. AI enabled machine monitoring, wherein you kind of do a health of the machine is monitored continuously. You will have predictive maintenance and analytics on the same, and again integrated AI powered inventory management. So to get into the details of this feature, what I would do is, if I can just take you through the existing software what we have, keeping in mind the interest of the time, I thought quickly if I can take you through the software what already we have. This is kind of hooked up on a test environment, but not connected to any kind of real-time mines now. But this is all having the features whatever I just explained. So if I just take you to the employee management, you can add an employee, you can kind of track his shift, you can kind of regulate what are the trainings he is supposed to go, what is the training he has already undergone. If you can also capture what are the different kind of accidents which has happened, all those things are brought on board here. Coming to the miners tracking, whatever I was talking is wherein you kind of do a live tracking of the miners using a kind of a hardware which is integrated to the hard cap, whatever they are wearing. So it gives you a kind of information of the live tracking within that mine, which will show you which person is where. If you have used Ola or Uber or any kind of these real-time cab aggregators, you will see where the cab is. So a similar kind of approach is taken here, where it will give you a location of the miner in the underground as well. So this particular feature is again integrated. It will give you continuous data. It also comes with a hardware device wherein we will have a two-way communication, wireless communication devices, wherein one-to-one or one to multiple people communication can happen. So if I was talking about the monitoring, which has got environment monitoring in it, the strata monitoring, the slope or landslide monitoring, wherein you will have a kind of add all the hardware devices, you will create nodes, you will manage those hardware devices, and then you will start getting the data. And once the data is started coming in, you can kind of decide whether if there is something which is exceeding the predefined regulatory values, then set out a notification or an alarm to the appropriate people, do a root causal of why it is breaking, what are the things which is breaking here, and then do an analysis as well. So within the monitoring itself, again, the strata monitoring, where we are using a different kind of sensors. As I was telling, we do have a convergence meter, load cells. So these are again integrated or hosted at prime locations or critical locations where we feel that, okay, the data has to be continuously monitored and kind of do a prediction on it, whether what is the chances that it might come down or when it might come down. All those things can be integrated or found out from this. And again, within the monitoring, we do have the slope and landslide monitoring, wherein again this is critical to an open pit mine, where you will identify different zones or locations where you need to add the sensors or place the sensors, and then fetch the data from there, It is going to give you a live information of the data based on the dates. You can do kind of play around a lot of information reports. Based on the reports, you can do decisions, whatever you want to take. So you can see the various sensors giving that particular information by the date as well. So going to another critical feature in an underground mine is the stowing practices, because there would be a lot of seepage of or water flow happening there. So you need to kind of keep on monitoring the water level by using sensors and see if we can uh, pull out that water when that exceedance limit is moved out. So you can also kind of do a comparison. What was the water level on a particular day? What was the water level on a different date? And then if there is a kind of correlation you want to do, you can do that. So e-governance is something wherein any of these mines, they have to kind of submit their submissions, whether it is annually or bi-weekly or monthly or 3 months in once. There are different reports wherein you can kind of integrate this with your inventory and then fetch the reports and send it directly to the PESO. So you can add the email address, subject, what is that you are doing. You can choose the file, so you can add the attachments and send it across to the regulatory bodies to whom you are supposed to submit these reports. We do have inventory management as well, wherein if you have your mines at multiple locations, you want to kind of manage the suppliers, manage the inventory, and figure out where you will have to take a decision of send them, where the ore is present, where the ore is not present, where you will have from which ore you can, mine you can send across the ore to the next whatever request has come. All those things can be kind of managed from the inventory management. The production monitoring is again to give you a kind of extensive details of what is being produced every day, what is the target you had, what is that you are at kind of real time data of how much has come in now, what is that you're lagging behind, what is your monthly report. There's a lot of features which is coming with the production monitoring.
Mr.
Machine
Desh,
monitoring is again
other modules you can skip and you can go, because we got a feel of what is being given. Okay.
Yeah.
Because we have one more speaker and
Sorry, sir. Yeah. I'll just take a last 1 minute. So machine monitoring is all again about the same platform. Whatever we have, the IoT platform for the industrial automation, which is again kind of connecting all the machines, fetching the data, and helping you to take decisions out of the data coming out of from the machines, whether it has to go for a maintenance or it is running on its operational efficiency, all those things. So the last thing is the weather monitoring, whether it is within the underground mine or on the surface. All these things are integrated into this software. So any other questions? So probably I'll drop down my email ID and phone number on the chat. So in the interest of the time, I guess this is something which we are very proud of, because we are associated with the government of India, and we feel that this is a mining industry is something which is slowly going into the industrial 4.0 solution implementation. Thank you, sir. Is that all I have?
Yeah.
Thank you so much, Sri Jayesh. I think a lot of information available with you on how IoT can help the mine. Thank you very much. Now, may I request Ms. Bandhavi to introduce the next speaker, Mr. N. Radhakrishna, DGM R&D, Singareni Collieries.
It is my privilege to read the profile of Sri N. Radhakrishna. Sri N. Radhakrishna is an alumnus of Kothagudem School of Mines, Kothagudem, having graduated in the year 1988. Later, he completed his executive MBA also from Kakatiya University. He is presently working as DGM in R&D department, SCCL. Sri N. Radhakrishna so far has 21 years experience in open cast mining and 9 years in underground mining. Attended the peer committee meeting of NITK Surathkal as member on 23 September 2019 and reviewed the NITK mining department activities and suggested suitable measures for improvements and industry needs. He well versed with advanced mine planning, slope stability, land acquisition, blasting techniques, blast seismograph software, and prepared scientific study reports on slope stability and blast induced ground vibrations. He undergone 1 month abroad training in open cast and longwall technology in China in the year 2012. He associated with different committees as member in fixing of benchmark PF in SCCL mines, in crop slope stability committee. As team leader, participated in restoration operation of NLCIL power plant unit 4 and 7 in the year 2020. He selected as best officer in the year 2017 from innovations. In-house development of standard penetration test (SPT) equipment for conducting of SPT for dump site, foundation characteristics, and geotechnical investigation for external dumps. He prepared papers submitted on development of pit slope stability guidelines for SCCL open cast mines, in particular in crop site slopes. Papers submitted in national seminar on mining and processing of raw materials for steel, cement, and power during 21-22 September 2019 at Hotel Malligi, Hospet, Karnataka. Role of information technology in mining operations, presented in the seminar on information technology in mining and way forward at IIE Hyderabad on 18 February 2020.
Thank you, Ms. Bandhavi, for the introduction. May I now request Sri N. Radhakrishna to proceed with his paper on probable areas of application of IoT in coal mining industry. Please.
Okay, sir. Thank you, sir.
Thank you.
Good evening to all, sir. Chandrasekhar sir, Bhaskar Rao sir, and Amarnath sir, and seniors, and aluminum members. And once again, good evening to all. Today, my topic is probable areas for application of IoT in coal mining industry. I will share my...
Yeah, you can share your screen, Radhakrishna.
Okay, sir.
The slides.
Is it okay, sir?
Yeah, it is opening. Full screen bit.
Okay, sir. Once again, welcome to all the delegates and participants. My topic is today probable areas of application of IoT in coal mining industry, particularly in SCCL. As you know, in SCCL, we are having 20 open cast mines and 25 underground mines. And we are also diversified our main core activity to other activities. Already established for 200 megawatt thermal power plant. Already we are establishing solar power plant and SME, POBs and some other diversified activities are going on in SCCL. In SCCL, always already our director in the initial chief guest told, we are all forefront in implementing latest technologies in its mines, and always I consider as a torch bearer in there. SCCL is the first coal Indian mining company to implement enterprise resources planning (ERP) to ensure optimal utilization resources and use of IT in optimization of the resources and implementing the safety standards. The progressive policies of the SCCL in encouraging the IT sector over the past few years resulted in the SCCL registering a 15% growth in the industry compared to the 8% national level earlier. This is the Singareni targets, 4,680 lakh kilometers will be removed every year, and a coal target of 70.5 million tons. Different technologies are latest technology introduced in mining industry. Now, present topic, what is IoT already told by Mr. Ramana, earlier speakers on the subject. Simply what we have done in Singareni regarding underground communication Wi-Fi system, and what other probable areas we require further initiatives or for other SNT studies we require in SCCL in particular in with respect to the coal mining. As you know, the coal mining industry lagging behind in utilization of the IT due to its prevailing working culture. You know, our working culture and a lot of scope is available for IoT usage in mines. Even the I2 gadgets available in the general market, we cannot be used as approvals are required from DGMS. This is one of the major constraint in our IoT implementation in underground mines particularly. Mining industry needs real-time monitoring detection system by using IT-based activity systems to increase the safety in mining industries. Use of information technology could be a blessing as it has been potentially to optimize the mining operations, resulting in higher production with reduced cost and also ensuring more safety to the miners, considering the high-risk pattern in minimum mining activities. There is a lot of scope for IoT enabled and driven technologies for better communication, underground operations, automated initiation, automated equipment in inaccessible and geologically hazardous environment. Mining industry needs real-time monitoring and systems using based IT systems to increase the safety of the mining operation to the next level. As you know, latest regulation CMR 375C, it is a mandatory for establishment of a system to track the location of the person working in the mine at any point of time. In this regard, SCCL has already taken steps for establishing the tracking system with this technology for tracking main and machinery in underground mine. In this regard, we already floated tenders earlier during Bhaskara's time, and in this we have Wi-Fi network system in 10 months. After successful implementation at one of the mine at PVK mine, but due to COVID or some other situation, it was dropped. And again, we are going to report the same tender. About the system, what we floated earlier, the underground locations in underground mines are so dynamic. What generally we keep some sensors at some place, it is not like that. It is a dynamic. The working places and locations will be moving and relocating to another site. It install and maintain the backbone data communication by OFC and our other Wi-Fi routers or any other suitable technology in any part of the open underground mine. It required locations, Wi-Fi routers access points shall be installed on the Wi-Fi cable to create hotspot in underground. The Wi-Fi routers access points shall be capable of capturing signal continually to monitor the real-time basis of the location. Wherever required, the Wi-Fi shall be established by opening the access points of routers. With this, the data transmission is one of the important from underground to surface for bin tracking, equipment tracking, production and equipment performance, monitoring of environmental ventilation status of the underground mines. These are the advantages of the Wi-Fi network in underground mine tracking. These are all the advantages of the Wi-Fi network tracking in underground mines. These are the general layout. There are different types of underground by shafts or inclines. Different activities will be monitored by this Wi-Fi network technology. These are the on-ground and what is the underground, what is the transport layer, different routers and these are the different technology to be used by. These are the different underground from sensors to the surface, data acquisition with wireless or with OFC cable. What are the technologies available in India? It should be implemented in our minds. So, in establishment of a network, there are available some haulage roadways or other return roadways, shafts. These are the available openings to the underground mines. We have to use these roadways for laying up the OFC cable, for Wi-Fi routers or anything, for tracking of the main and machinery with the RFID tag, radar, or similar other suitable accessible systems. One system are made available same data, the rate of production and safety and online environmental system monitoring the underground mine. These are some gas monitoring systems so that you can directly you can monitor from surface. So, in main challenge in underground mines is it should be intrinsically and frame proof. We should require approval from the DGMS. Some in SSL we are having the all other different equipment. We should have a RS 485 with Modbus protocol system of data conversion to Wi-Fi and Wi-Fi network in TCP or IP protocol, as and when essential procure the IP-based wireless telephones or video camera shall also should be integrated in the present system. Generally, underground we are having the voltage of 110 volts, and there should be a power backup of 16 hours and more. So that with all the system in any surface type automatic control center, we can monitor it from surface control room, all activities of the underground. This is the main aim of the our Wi-Fi underground system. Number of firms participated in that, but due to various reasons, it was dropped. Further requirement in our Singareni, for particularly already earlier speakers told some subjects, we need data monitoring system in underground as well as in opencast mines. Development of mining related software, scanners, sensors. Indigenously, this is main important is indigenous. We are having the different types of scanners or some other. It is all outside. You have to develop indigenous development is very, very important. Steel of panel gas monitoring, remote located water dams, and what is the strength details of water dams. By remotely, we can check the just water dams in Telangana government. Ventilation stopping, some other monitoring, blasting operations. Stope stability is another important subject in open cast mines for continuous deformation of the benches or slopes so as to help in protecting the life of the mines and mining equipment. Other important subject in open cast mines is M maintenance, M tracking in OC mines. Another subject is dumpers tracking for coal grade. In different grade coals we produce in open cast mines. Each grade in each shift, what is the amount of grade we can get? What is the percentage of the other type of grades? It is very, very important, particularly in the open cast mines. These are the, as the earlier speaker one told, it is a very difficulty to monitor blast vibrations nearby villages. Remotely type of vibration system is also available. That should be also implemented in our mines so that any nearby villages we can monitor the vibrations by using IoT. These are the other important subjects. Slope monitoring, physiometric also some difficult without going and measuring the water levels. We can use the sensors and by remotely we can measure the water levels also. Some other important in open cast mines drilling. By using GPS, we can maintain the drilling pattern and every blasting pattern we can use there is a scope for improvement in this also. Like this. Yeah, another important is machine learning and artificial intelligence. It is very, very important in particularly for improvement of the performance of the open cast or underground. Example, some fragmentation, whether optimum or acceptable, not acceptable. These are what are the important button. These are all the sub parameters. With this artificial intelligence, with the available data, we can design any type of parameters like this. Now, conclusions. SCCL has been a pioneer in application of information technology in coal mining in India for optimum utilization of available resources with maximum accuracy and at least possible time. And there is a lot of scope for IoT in mining industry. Scope for new initiative for S&T projects. Even in S&T projects, there is a lot of scope with small, like M performance by avoiding trip counters like this. Like some such type of S&T projects we can take so that we can, even earlier, our coal secretary also told there is a lot of scope for improvement of M performance. And other for automation is very, very important. And you by using machine artificial intelligence are like this. There is a scope like the last, like every person we have scanning, we can by person we can scan, we can see the each and every part of the person. Like this in mining operations also, we have to scan by using this IoT technology. It is the main aim in future in Singareni by Atmanirbhar Renew. This is like this. We are using ladders and other related technologies in open cast mines also. By my last and to the researchers or everybody is available. This any activity we can by user friendly development is one of the important. Another one is the user friendly development is very, very important. Anyone can see with cell phone or with normal man can also normal mining engineer or any workman or supervisor. Technical development in our mines is very less, so that with the normal cell phone you can monitor everything in open in any mines. This is the main. Thank you, sir.
Thank you, Mr. N. Radhakrishna, for the presentation on probable areas of application of IoT and artificial intelligence. Thank you very much. May I now request
Sir,
Ms.
please
Sai.
close your sharing, sir.
May I now request Ms. Saiti to introduce Mr. B. Bhaskar Rao, who is going to give the concluding remarks of this webinar.
I'm very glad to read the profile of Sri B. Bhaskar Rao, Director PNP, retired, the Singareni Collieries Company Limited, a government company, Telangana. He was born on 11 July 1960. Sri Bhaskar Rao is an alumnus of Kottagudem School of Mines, Kottagudem, having graduated in the year 1982 and immediately thereafter joined in the Singareni Collieries Company Limited. He is holder of First Class Manager Certificate of Competency, Coal, completed his PG Diploma in Computer Science from Central University, Hyderabad. He joined in the Singareni Collieries Company Limited as mining graduate trainee and elevated to the position of Director PNP and retired during the year 2020. Work experiences. Total experience 35 years. At middle level management, worked in highly sensitive extremist areas for 8 years and have handled challenging industrial relations. Key positions include General Manager, Information Technology for 7 years, during which SCCL has successfully implemented ERP system with SAP. General Manager, Adriala Longwall project for 5 years, during which time the prestigious high-capacity Longwall is constructed for the first time in India. Worked as Head of Department for Information and Project Management, Project Planning, and Corporate Planning and Projects. He is well known for his technical contribution as General Manager for the launching of Asia's largest and advanced technology in Longwall in Adriala project of the Singareni Collieries Company Limited. He is considered to be an expert in information technology and has been instrumental in the implemented ERP system with SAP. He visited many foreign countries to familiarize with various advanced technologies there and introduced them in the company. He is very sincere and honest officer. We are privileged to have his presence in this webinar despite his busy schedule.
Thank you, Ms. Saiti. May I now request Mr. B. Bhaskar Rao to proceed with his concluding remarks and other interactions.
Thank you, Saiti, for the good introduction, and Amana sir. Yeah. And good evening to everyone. I think most of the people know Telugu also. I can use a mix of the here and there. First at the outset, first I would like to mention that everyone is mentioning that I think most even the Singareni were mentioning that I am an IT expert and all that, but we must understand that we are in 2000. Whatever we see in 2000 today is not relevant. Today we see many technical people have impressed with many people coming up, especially from the mining community to the IT. So I think probably if I need to share my contribution, probably I'm a little better in integrating the technology to the field conditions. From our generation, I think I'm little understandable. That is, except that I don't think I'm really not an expert, and I really appreciate the papers and all that. Time is late. I will not take more time, but just I'll try to first mention what are the key contributions from each of the paper. Because I don't want to repeat all the things, but I'll summarize from an industry perspective, and most of the students are also there. I will not try to be too deep into the industrial perspective, but primarily, I think we need to integrate the theory to the practice. I think that is what is my passion, and I'll try to do that. Okay, a little bit of that. I think the first paper by Ramana sir was extremely good because it has laid a very good foundation to understand for everyone who is not conversant with any of these things to be what is an IoT and all that. And it has taken a very good examples of simple life examples and then integrated to the mining requirements, and then what are the things that are coming up in the mining environment industries and how it is done, and what are the challenges in the mining. I think he has set up a very good platform on which the further discussions to take place. Personally, I'm very, very impressed with the Mahesh's presentation because it is exactly the same where I was looking into that. In fact, I was personally interacting with many times with the industry, IT industry, about trying to get onto that, because at that time I didn't find anyone like him who has, because he has come from a core. I think I'm very impressed mainly because he has a clear field understanding of the mining, and he being entering into the IT field, I think is making a very good blend, and really a product of design from the perspective of the design of the product. It is extremely good for the mining. He has touched upon these layers and all that, but hardware and overcome progress and all those things. But primarily, he has impressed upon everyone to know about these connectivity challenges, and of course, in practice, using the truck itself as a communicator of the data also, apart from the material. I think that is what, if I can put it in simple words, and the shadow gens handling and all that. These are the challenges we have faced in OITDS when we were implementing also. We try to find a different ways of finding a solution of the shadow zones and all that. So it's basically a business solution. He has made in a very simple terms the technology onto that. I think that is a good, really, most of the industry people must be really appreciating that product. Of course, Karthik's paper was definitely, he's a scholar by profession or by qualification, and it is a scholarly paper. Definitely, I think they lay the foundation for the real industrial papers. It's main thing that he has repeatedly mentioning a real challenge for which the mining industry should understand is that about the requirement of the smart sensors. It is mainly because most of our sensors which we use being a very limited market. It's not that like a refrigerator or anything where you have a huge market. So these sensors getting into a smart sensors is a huge task. Not the technology, but mostly a commercial part, because the affordability, if you take onto that, to do really those things, it is not an easy thing, and that is where probably we will have some challenges. But as far as the technology is concerned, I think it's a very good understanding onto that. Of course, similar is the JS paper, where it has a clear integration of Simpers impact is coming, where a lot of mining field requirements are also coming into that, the digital mine concept, and getting on some of the things which is mentioning. If you look into what integrate the JS paper with Radhakrishna's paper, I think the Singareni tender, what we have really, I think I was personally involved in the tender drafting, that all these requirements we try to build into a simple scale into an underground mine. Okay, these are the broad parameters. So it is clearly a good mix of good foundation laid down and then applying to the industry and really into the field level of tendering. I think the chronology and the total this thing has been very well, and I congratulate the organizers and all the speakers for the wonderful contribution. And summarizing 2-3 points very briefly, I'll try to put a platform onto that where our industry lies and where we really from these papers can take forward to a relay industrial environment. See, if we see the first paper also, the same on level 1, level 2, if we in the field, in our sense, if we need to talk them into our industrial perspective, and normally when we talk of a artificial intelligence, machine learning, when we are talking of these are the advanced things, the foundation starts from the basic digitization. That is, first any industry should start doing a data, bringing all our operations into data system, digitization, and then integrate into a database and ERP. That is the foundation, without which I don't think nobody will think of an IoT or other things. So the basic industry, if you see Coal India right now, they are implementing SAP. So our industry in the mining, especially in our country, we are very, very in the initial stages of digitization, where our basic things are not yet computerized. That is one first thing that we should understand. So these things to happen into the industry, the other things also should happen simultaneously, but these things cannot happen in the industry straight away. The second thing is, once you have an integrated system of SAP, something like that, the other part is the simple automation of the equipments. Most of these equipment are inbuilt now today with digital measurement of the things, digital dashboards and all that. In the equipment level, there is a digitization is happening. Once in the equipment level it is happening, they need to be converted within the equipment. I think there will be printed circuit boards and all that, where the equipment itself works in an intelligent way. I think this is happening in most of the equipment. If you see the Caterpillar, I was last week I was looking at the Gemco and all that, they were happening. But once there is individual equipment is there, as someone is mentioning, these individual equipments have to be working to sync with others, which is a system integration. Whether what are the each equipments, whether they are coming out with same standards, whether we need to outside. So wherever, see, if you take Adriana project, if we have taken all the equipment as a package, then they integrate. But if we buy the individual machines, how the integration should happen is one challenge, to make the automation as the equipment as a package. That is sharing of information, shake hand between the equipment. So this can happen at the lower level. You don't need a big IoT system onto that. If there are two equipment working there, if you can make them like a sequence control and all that, it can happen at a lowest level. So that can happen if the equipment is ready. That is our equipment's readiness. We must be able to see out to that. The next part of the data acquisition is the ground data and physical data. So we must be able to have the sensors, as people have already pointed out. These sensor areas is again an independent subject, where we can try to convert our existing sensors wherever we are doing into an intelligent sensors, where they will become an IoT ready. That is, it can be our gas monitoring systems, it can be our other strata monitoring sensors. All these sensors, if we can make them IoT ready, any IoT system, it get integrated easily. So these sensors having a proper systems, and when we buy this type of things, that I think that is where there should be an IoT ready sensors equipment. We should be able to ready. Once these individual sensors are ready, then we must have a business integration with these sensors and to the business. This to happen, we are talking of machine learning and artificial learning. If this learning has to take place, there must be somebody to teach. See, learning doesn't come automatically. Unless there is somebody to teach, this learning has to come. This teaching has to come from the industry. Now, this is where we really lack, and where if we are able to know the business logics and get this data and integrate, that's the step forward onto that. I think this is the roadmap if we look into that, and if we work together, I think these things will happen in Indian industry also, and our mining industry does not need to lag. So I congratulate the excellent initiative taken by the organizers. This is a very good subject where you need to, and these type of things can definitely happen only from these forums like this, where we can bring together the industry, academicians, and the IT industry. And if this happens, I think the way forward is good. Thank you.
Thank you, Mr. Bhaskar Rao, for wonderful summing up and giving your expertise in the field. And I'm sure with all of you behind us, we'll take things forward, not only for the students, but also for the mining industry. Thank you very much. May I now request Mr. Satish Kumar to propose the formal vote of thanks.
Thank you, sir. It's my privilege to read vote of thanks. Finally, I would like to take this opportunity to record my heartfelt thanks to Sri S. Chandrasekhar, Director of Operations, Chief Guest of today's webinar, for the right logistic support and excellent message given to the students. We are privileged to have his presence in this webinar despite of his busy schedule. Thank you, sir. I also thank to Dr. Ramana, Principal KSM, briefed about introduction of IoT, and Sri T. Mahesh, briefed about application of IoT for optimization of fleet in opencast projects. And also thank to Dr. Karthik, enlightened the students about application of IoT in opencast projects. And also I thank Sri Jayesh, given his presentation on digital mines powered by IoT. And I also thanks to Sri N. Radhakrishna, DGM R&D, explained probable areas of applications of IoT in our company, SSL, that is. I thank to Sri B. Ramesh Kumar, President Alumni, for his support to recognize this, organize and to become success of this webinar. And I also thank to Sri D.N. Prasad, Advisor Projects and member of Alumni, for his valuable support. I thank to Sri B. Bhaskar Rao, retired director Singareni, and active alumni member, to spare his time to sum up on whatever the presentations given as of now, for his extraordinary talent in IT industry. I also thank to Dr. M.S. Venkatramaya, retired GM SCL and General Secretary Alumni, taken a lot of pain and spare his valuable time to become success of this webinar, today's webinar. And I also thank to Sri K.J. Amarnath sir, retired CGM SCL and overall coordinator of this alumni, and who is the behind coordinating of today's webinar to become this success. And also thank to Sri K. Ravishankar sir, GM CDN and alumni member, for his active support and positive support. Thankful to Sri B. Mahesh, Deputy Mayor, and D. Venkatesham, Deputy Mayor, towards their support always. And I also thank to Sri C.H. Venkatramana and all other faculty members in the OU in the mining industry to become success of today's webinar. And also thanks to Mr. Ratnam, who is the background operator of this today's webinar from Institute of Engineering, for his excellent support. And also thank Ms. Sahiti and Bondavi, ME mining engineering students of Usmania University, to read the profiles of today's chief guest and other speakers. We have been fortunate enough to be supported by a team of very motivated and dedicated senior faculty members. That is K.J. Amarnath sir and Dr. Venkaramaya sir, who is in the mining department at OU. Last but not the least, very much thanks to the other alumni members and other faculty members and other professors and all the students who are joined in today's webinar to become grand success. Thank you, sir. Thank you so much.
Thank you, Ms. Satish. Over to Dr. Venkatramaya, and for final national anthem from Mr. Venkatratnam.
Thank you very much, Amarnath sir. Because of paucity of time, we could not give time for interaction. In any case, I am thankful to all the seniors, particularly V.S. Rao garu, Fasiuddin garu, Ramohan garu, and Dattatreya garu, D.N. Prasad, and Rannath Ishwar. Many of them were available in the meeting. Probably we will continue this trend of having discussions on IoT and artificial intelligence, machine learning. Slowly we will have some more discussions. Sorry for not giving the time for all the interactions. In any case, thanks for all the seniors who have participated. And we have excellent faculty from NIT Surathkal, NIT Rourkela, and IIT Kharagpur, Dr. Srinivas, all have come into the session. So we will try to discuss once again on this subject. The interest shown by you has motivated us to have one more meeting on this. Thanks. And now may I request, because of I think it is already 7:20, we are behind the schedule by nearly 1 hour. We will end the meeting, and I request Ratnam to please play the national anthem.
Okay, sir.
Thank you.
Thank you.
Thank you.
Ratnam?
Yes,
Jai Hind, and thank you very much.
Namaste to everybody. Jai Hind, Jai Bharat. చాలా సంతోషం, మన చాలా మంది సీనియర్స్ కనబడ్డారు. లక్ష్మీనారాయణ గారు ఎక్కడ ఉంటున్నారు ఈ మధ్యలో? మా మెస్ సెక్రటరీ ఈ మధ్యలో ఎక్కడ ఉంటున్నారు మీరు?
Can we play boomerang ball?
లక్ష్మణ గారు మీరు మ్యూట్ ఉన్నట్టుంది, లేదా నా వాయిస్ వినబడుతుందో లేదో? అఫీషియల్ మీటింగ్ అయిపోయింది కదా, మనం ఏమైనా మాట్లాడుకోవచ్చు.
నేను వరంగల్లో హనంకొండలో ఉంటున్నా.
చదవకుండా ఉన్నారు. మేము COVID-19 అయిపోతే మెల్లగా ప్రయాణాలు ప్రారంభిస్తామండి.
ఇక ఒక 1 month తర్వాత.
అదే ఈ COVID-19 అయిపోతుంది.
అవును అవును.
ఎప్పుడు అక్కడ వచ్చేది ఉండే మన రాధాకృష్ణ, మన గురువయ్య గారు ఎప్పటి నుండో చెప్తున్నారు వాటిల్లి అన్ని వచ్చింది. కొండయ్య గారు కూడా చాలా రోజుల తర్వాత చూస్తున్నాం. కొండయ్య గారు ఎక్కడ ఉంటున్నారు?
కొండన హైదరాబాద్ అయితే.
హైదరాబాద్ లో ఉంటున్నాను. జయంత్ గారు బాగున్నారా?
COVID-19 కదా, అంతా ఇట్లనే ఆన్లైన్.